Welcome back. In the previous video, we have seen how using dependency injection helps us writing unit tests, and also we have seen how we can switch different implementations based on the configuration. In this video, we are going to use Spring to do the dependency injection, and then we'll learn how Spring's dependency injection works behind the scenes. Here, I have a simple Maven project with the same code we have used in the previous video, but it is not a Spring Boot application. It's a simple Maven project, and we just have Spring context added as a dependency. It's not a Spring Boot based application. And we have the same code base, like we have background verification service interface, and then there are two implementations of it. And we have loan service, which is taking background verification service as a dependency through constructor. And we have apply for loan method. And we have a simple bean loan request with few properties. And here is our main application. Just assume we are building a simple console application, and we need to get an instance of loan service, and then we constructed a loan request and then finally called apply for loan. And based on this code, we are going to either get approved or rejected. So here, how do we get an instance of loan service? So we are going to use Spring's dependency injection, and then we will get the bean out of Spring's application context. So in order to do that, what we need to do, first we need to annotate our beans with the add component annotation. And for this example, I want to use background verification service. So here I have already added add component annotation. And how do I create application context? Because I want to use annotation based approach, so I can create annotation config application context and create. Here I can pass what are the base packages I want Spring to scan and identify the beans. So here I would pass com.sevalabs.da. So that is where all my code in. So I'm going to pass that as a base package. So once I have this application context, I can look up the bean context dot get bean, and I want loan service dot class type bean. Okay. Now I have the loan service object, and I have loan request, and then I'm calling for apply for loan, and let us see. So here we can see loan is approved because I am giving my unique ID P100, and as per our configuration, it's going to use this background verification service, and here I am simply returning true. And in loan service, if the score is less than 3, it's going to be sanctioned and return true. So that's why we can see loan is approved. So it is as simple as that. By using Spring's dependency injection capabilities, we simply mark down beans as Spring components using annotation, and we also annotated add component to our dependent bean. So Spring is going to figure out, okay, I need to create a bean of background verification service, and then I need to create a bean of loan service and then inject through constructor. Okay, it works. So we have used Spring, and we have added a couple of annotations to our beans, and then we created an application context specifying the base package, and we are able to get our loan service bean looking up from the application context, and it is working fine. But how exactly it is working, and how Spring is able to do this dependency injection? So let us understand the inner workings of Spring's dependency injection, so that we'll have a better understanding of how a Spring dependency injection work. Okay. You may ask, why should I bother to learn inner workings of a framework? Why can't I simply just use it and then move on? Why should I learn? So the reason is Spring and Spring Boot is a large ecosystem of modules, but Spring's dependency injection is a very core concept, and you will be using that throughout the modules. Like you will be using that irrespective of whether you are using Spring Data, Spring Security, Spring MVC, and plenty of other modules. So this is a very core concept, and getting a good idea about how Spring's dependency injection works is going to really help you to understand other modules which are depending on this core Spring dependency injection very much. So I'm going to go deep dive into how Spring is doing this dependency injection behind the scenes. Before exploring how Spring is doing a dependency injection, let us think for ourselves for a minute. How would I implement dependency injection if I was supposed to implement this feature, this framework? Okay, so here we have annotated our beans with some annotation. Okay, and how do I make these beans instances and then inject that instance into this loan service? Okay, so the way I would think is, first let me write down here. So first I would scan all the classes which contain and identify which classes has add component annotation. Okay, so first I'm going to read through all the source code in our project and then see which classes has add component annotation, because those are the beans we need to instantiate. And let's assume we scan through all this code and then we identified, okay, we have loan service and we have background verification service. These are the two components that we need to create. And also first we need to create an instance of background verification service, and then we need to instance loan service by passing that instance to this constructor, right? So how do we know? First we need to create this background verification service and then we need to create loan service. It's using reflection. So here, once we identify all the beans, what we can do, we can identify the bean dependencies using Java reflection. So this Java reflection, using Java reflection, what we can do, we can inspect the metadata about any classes. What I mean by metadata, like I can, at runtime, I can take any class and I can see what are the properties defined for that class and what are the constructors defined for that class and what are the methods that are defined for that class and what are the modifiers it has. So I can get all this metadata about any class using Java Reflection API. So once I identify all the beans that has add component annotation, I can use Java Reflection to identify what are the dependencies each component has. So here I can see background verification service and I can see, okay, it doesn't have any other dependencies. And I can see loan service and I can read what are all the constructors defined in this class and what are the types of dependencies it is expecting. Okay, using Java Reflection. Once we identify the dependencies, we can kind of follow this recursive approach. Okay, first, if I try to create a loan service object first, I can see it needs a bean of type background verification service. And then first I try to instantiate background verification service. And here it doesn't depend on any other beans. So I can instantiate this an instance for background verification service. How? Again, using Java Reflection API. We can use Reflection API and create an instance of it, and whether it has any inputs through constructor or without any inputs, we can use Java Reflection API and create an instance of it. Once I create this instance, I can go back in that recursion cycle and then try to create an instance of loan service by passing that background verification service instance to this. Okay, so that is how the third step would be: create instances of the beans using reflection API. So this way I can instantiate all the required beans and then create a full-fledged application context having the fully instantiated bean hierarchies. Let us start understanding how Spring is scanning all the classes and identify which classes has add component annotation. So let us create a class called Spring DA and create a main method, and here we have Classpath scanning candidate component provider provided by Spring. No wonder there are jokes on Spring's long class names. Okay, let us instantiate this class, and here we need to specify should we use default filters or not. So what does that default filters means? Okay, so by default Spring has this core annotation of at component, right? And then there are more specific variations like at repository, at service, at controller, like that. But the base component is at component, the base annotation is at component. So by specifying true, it's going to read all the classes that is having at component. But if you are looking for any specific annotation, what you can do, we can pass false, which means it is not going to look for add component, and then you can specify exactly what annotation you are looking for by using scanner dot add inclusion filter, new annotation type filter, and let's say we are looking for component, add component annotation, right? We can specify. Let's say if we are creating our own annotation, we can pass okay my component or whatever annotation that you are looking for. So after specifying this an inclusion filter, what we can do, scanner dot find candidate components, and here we need to specify base package to tell Spring where to look for the beans. So here I'm going to specify look in this com.sivalabs.di package, and what it is going to return, it's going to return a set of bean definitions. What does a bean definition has? Let us first iterate and then print and then see. Okay, so each bean definition has a lot of information about each of those components in the sense a bean. So here we can see what is the bean class name, and one bean can depend on other beans, and what are the constructor argument values, and there are lots of information, metadata information. Spring is already scanning and holding it. Is it a prototype bean? Is it a singleton bean? So like that you have a plenty of information scanned and hold. So here first let us simply print this out. Okay, so let us run this. So it identified there are two beans which are Spring components, background verification service and loan service. How? Because we annotated them with add component. Okay, so this Spring utility Classpath scanning candidate component provider help us to identify what are all the beans that are annotated with add component annotation, and we specified where to look for the beans. So that is how Spring is able to identify what are the potential Spring components that it is going to create the instances for. Okay, so this is step 1, identifying all the classes that has add component annotation. So the next step would be identify the bean dependencies using Java reflection. So it is going to do internally, it has lots of implementation, but let us simply see how we can use Java reflection API and identify what are the constructors each of these beans have. Okay, I'm going to move all this code into a separate method. Okay, so next let us see how we can get what are all the constructors a class has using Java reflection API. So let us create static void print constructors. So we are going to specify what is the class we are interested in, type okay. So how do we get constructors of any given class using Java reflection API? So what we can do, type dot get constructors. We can call get constructors to return what are all the available constructor, because there can be one or more constructors in a class, so it's going to return an array of constructors. And here let's assume in our case just we have only one constructor, and let us constructors take the first one and get what are all the parameters it has. Get parameters. So if you look at a constructor here, it has one parameter of certain type, right? So we just got get constructors, that means it's going to return one constructor, and then we are trying to fetch what are all the types of parameters it has. So here by calling this get parameters, it's going to return a parameter array. So in our case, suppose if I pass to this method, if we pass loan service, it's going to return one constructor, and it's going to have one parameter of type background verification service. So here if we iterate over parameters, sort parameter dot get type. For now, let's just print what are all the constructors we have and print each parameter type. So let us call print constructor, and I'm going to pass loan service class. If I run it now, so here it says parameter type of interface of this particular type, background verification service. So that is how we can do identify the bean dependencies using Java reflection. So here this is how I can identify what are all the dependencies for a given class. So let's say if I specify background verification service, okay, so here it's not going to print anything because it doesn't have any dependencies. Here we don't have any constructors defined. That means it's going to have a default constructor without any parameters. That's why we are not seeing any parameters over here. So that is how we can identify what are all the dependencies a particular bean has using reflection API like this. Let's say if we use loan service, and in loan service we not only have background verification service, let us say we have another class called loan repository, okay, and here Again, I'm going to annotate with add component, and I'm going to add it as a dependency of loan service. Start loan repository equal to loan repository. Okay, now if I go back to our main method, sorry, Spring TI class, here if I pass loan service, earlier we have seen only one parameter of type background verification service. Now if I run again, it is going to show there are two dependencies. One is of type background verification, another one is of type loan repository. So that is how you can identify what are all the dependencies a bean has using Java Reflection API. Okay, so the next part is how to create instances of beans using Reflection API. Okay, so let us go back to our Spring TI. So here I'm going to comment out this method call and create a new method called create beans using reflection. So here what I'm going to do is I want to create an instance of loan service, but before that I need to create an instance of background verification service and loan repository and then pass those instances to loan service, right? But I'm going to do all this using reflection API. So first we need to call class start for name and then specify fully qualified name of the class that we are going to create. So here I'm going to give background verification service dot class dot get name, and it's going to load this class, and here I'm going to call get declared constructors. So here a class may have one or more constructors, but in our case we did not specify any constructors explicitly for background verification service, which means there is only a default constructor. So I'm going to take the first constructor and then call new instance. If your class is taking any constructor arguments, we need to specify those arguments here, but here we don't have any arguments for background verification service constructor, so I'm not going to call pass any values here. So first let us declare it as throws exception. Okay, and here it's going to return an instance of background verification service. Okay, but it's a generic method call, it's going to return generic object, so we need to typecast it. So I'm going to cast it to background verification service. Okay, so now we have an instance of background verification service. The next thing is we need to create an instance of loan repository as well, because our loan service has a dependency on loan repository as well. So again, create in the same way class dot for name loan repository dot class dot get name dot get declared constructors, and again we don't have any constructors over there, so I'm going to call new instance and it's going to return loan repository. I'm going to cast it to loan repository. Okay, we have both background verification service and loan repository. We are going to follow in the same way, class start for name, and this time it's going to be loan service dot class dot get name and get declared constructor. And again, because we explicitly defined a constructor, it's not going to have any default constructor, so we know there will be only one constructor. So I'm going to take the first constructor and then call new instance, but here I need to pass the expected dependencies for the constructor. We already have background verification service and loan repository, so I'm going to pass to this new instance method, and here it's going to return a loan service instance. And Okay, fine. But are we sure it's going to work fine? Let us test that. Let's call this function and again just declare throws exception, and let us go back to our main method and take this, go back and here. So here we have loan service instance created via reflection API, and we created a loan request and then calling apply for loan. So I'm going to call this method. Yes, it is working fine, right? So that's how. Okay, let us verify. What if I want to change background verification service to use mock background verification service? Okay, let us try that. Go back and instead of this, okay, so here I used mock background verification service instead of background verification service, and here if I call loan is approved, but according to the behavior, if I pass anything apart from these unique IDs, it should reject, right? Let us verify that by changing the unique ID from P100 to P200 and then run it. So now loan is rejected. So we are sure that it is using mock background verification service. Okay, so now coming back to our 3 points. So this is how we can use reflection API and create the instances according to our needs. So these are all the background implementations Spring is doing, like it is scanning all the classes and then identifying the beans that are having at component annotation. And then we have seen how we can identify what are all the dependencies a bean has using Java reflection. And then once it identifies those dependencies, it can use the reflection API to create those instances and then pass those instances to create the instance. So Spring is heavily using that reflection API to do all these things in the background, and then it is creating all these full-fledged services and then providing them via our application context. So these are all the things that is happening behind the scenes, and we are simply able to create annotation application context and then specifying this package, and it is doing all this behind the scenes, and we are able to simply call just give me whatever the bean I want, and it is going to simply return that bean. So this is how Spring is doing all this annotation magic behind the scenes and then instantiating all these classes using Java reflection API and providing us the full-fledged constructed beans. So we have seen how Spring is doing the dependency injection and how behind the scenes it is using reflection API and its own lot of annotation processing logic to fully construct the beans, required beans. But the question is, in order to follow the dependency injection design pattern, should we always rely upon some frameworks like Spring? Of course not. Just as we have seen, it's not really any magic. It's kind of an approach how you instantiate dependencies by passing the dependent objects to it instead of constructing its own dependencies in the class directly. So we don't even need to use any framework. Let's say we are building a small application and we hardly have a handful of classes like 10 or 20, and we don't want to have an overhead of using heavyweight frameworks. So can't we do dependency injection? No, we can do that. In fact, let us try to create our own bean factory and then see how we can create a similar bean factory, just like the way we have here annotation config application context, right? Let us create our own bean factory and see how we can do that. Okay, so first let me create my bean factory. So here we are not going to use all this reflection magic and everything because our application is small and we know what instances we need to create and in what order. So I'm going to straight away create the beans that are required only for my application. I'm not going to create a generic implementation of dependency injection container over here. So let us see how we can do this without having to use any framework. So I'm going to create a map, private map, which holds a class type as the key, and it can be any object as a value, and let me name it as beans. And here I'm going to call a method to initialize this map. Okay, so here I'm going to create bean map and initialize it, and I'm going to return it bean map. Okay, so because I know what classes I have in my application and I know the order I need to create, I'm going to just create using plain Java code. Like, okay, first I want to create an background verification service, and I'm going to use mock background verification service. And next I need loan repository. I'm going to create new loan repository. Next I need to create loan service, new loan service, and pass background verification service and loan repository as dependencies. But before that, I'm going to put those beans in. So if it is background verification service class, I'm going to store background verification service implementation. Again, I'm going to use, and for loan repository type, I'm going to put loan repository. Similarly, for loan service, I'm going to put loan service as the object value. So here, once I have initialized this map and then instantiated all the objects that I need for my application and then store each type along with its value, and now I can expose a method like public. It's going to be a typed value and get bean, and specify what type I want, and here I'm going to return from beans dot get of the type, but it's going to be a generic one, so I'm going to typecast it to T. Okay, so this is how I simply created my bean factory. So now if I go back to our main method, instead of using annotation config application context and creating loan service like this, what I will do, I'm going to create an instance for my bean factory, and I'm going to create a loan service by looking up bean factory dot get bean of type loan service dot class. Okay, so here I'm going to run this and then see loan is approved, and if I change it to P200, it's going to reject the loan. So it is as simple as doing like this, but for small application you can still follow dependency injection because there are only a handful of classes, and then you know the order to create, and then you can hold the beans, and wherever you want to, maybe you might want to make it as a singleton class and then return whenever somebody asks for a bean, you simply return that. So the point is, in order to use the dependency injection pattern, you don't have to always rely upon frameworks like Spring or anything. If it is a small project and you don't want to use any heavyweight frameworks, you still follow the pattern. So the idea is you don't instantiate the dependencies directly in the class itself. You take them as a constructor arguments so that you give an opportunity for the a third party framework like Spring or another utility that can create the instances and then pass it to the components as a constructor arguments, so that there is a flexibility how you want to construct your object. You are giving an opportunity to other frameworks or utilities to construct in a different ways. Here I can just read from a configuration file and then decide which implementation I want to use. I want to use mockbean background verification service, or I want to use this actual background verification service. I can read some configuration file and then decide which implementation I want to use. So the idea is, do not directly instantiate your dependencies here. Instead, take them as constructor arguments. That is the key point of dependency injection. We have talked about what is the dependency injection and how to do the dependency injection using Spring, and how we can roll out our own dependency injection if the project is small and with only a handful of classes, and what is the purpose of using dependency injection in the first place. So, but there is a lot more to what Spring has to offer. Like right now we simply annotated with that component, and by default it's going to create it as a singleton bean, and you can customize a lot of things. Like you can change the scope to instead of singleton you can make it as a prototype bean, and you can mark it as a lazy bean. So there are a lot more customizations you can do, but we're going to learn about these additional features in the future videos. Okay, so for now I think we have a good idea on dependency injection now, and we are going to see what are all the other design patterns that Spring is leveraging behind the scenes in the upcoming videos. Thanks for watching and stay tuned for the upcoming videos. Bye bye.